Hi everyone, the program I'll be explaining today is the addition of two polynomials using linked lists. This program follows the concept of a singly linked list, and every node in the list contains three members: coefficient, exponent, and the link to the next node. Here in line number 11, I used typedef with structure to define a new data type, and I named it as P. Also, I defined four pointers to the structure globally in line number 12. So poly 1, poly 2 and poly 3, they are considered as the head nodes, which means that they are pointers to the first node of each linked list. Poly 1 will point to the first given polynomial, poly 2 points to the second given polynomial, and poly 3 will point to the result. I also declared temp, which will be helpful in traversing through the code through the linked list later on in the code. Now let's look at the main function. This is the main function, and as you can see here in line number 96, 97 and 98, we allocated three nodes from the heap memory dynamically to poly 1, poly 2 and poly 3. Now we ask the user for the first polynomial as input. After this, the push function is called from the main function, and pointer poly 1 is passed to the push function, as you can see in line number 100. So now as we pass poly 1 to the push function, let's look at the push function. In the push function, as you can see in line number 13, so the pointer poly 1 which we passed in the main function is received by num, pointer num in this function. And you can also see I've initialized two variables I and term to 1 and 0. So I is considered as a counter variable, which will be helpful in iterating the while loop. The term variable importance I'll explain you later. So we can see in line number 16 that we have used a while loop. So the function of this while loop is to add terms to the polynomial if the user wants to do so. So now we can see while is I is equal to 1. So since we have initialized it as 1, so the control will go inside the while loop till line 18. In line 18, I have asked the user enter coefficient of term %d. So I have given term plus 1, which is 0 plus 1. So enter coefficient of term 1. So now I guess you can understand why did I use the variable term. It's to tell the user which coefficient and exponent, which term's coefficient and exponent are you giving to the computer. So I'm asking the user for the coefficient of term 1, and we accept that into the coefficient field of num. So num, as of now, it's pointing to the first node in the linked list. Since it's the first time we are entering this while loop and the function, so the num is pointing to the first node, and the coefficient will be stored in the coefficient field of the first node, which is pointed by num. It's the same case with exponent. So we ask the user enter exponent of term 1, and the exponent is accepted and it's stored in the exponent field, which is E field of the node pointed by num. Now in line number 22, you can see that there's another node, another block of memory being dynamically created, and that address, the address of that new block of memory is stored in the next field of the node pointed by num. So suppose if I have only one node right now in my linked list, in line number 22, I'm creating the second node and the address of that second node. Suppose the address of that second node is 2000. I store that address 2000 in the link field of the first node. So this will create a link between the first node and the second node. So now after line 22, the first node is totally filled. Our coefficient field is filled, our exponent, and also the link field is filled. And we also have a second block of memory created. In line number 23, you can see num is equal to next of num. So this means that the address which we got just now of the block of memory we created, that 2000, which I just took an example right now. So suppose if the address of the second node is 2000, that 2000 will be stored in num also right now. So as you can see, num received poly1, but that doesn't mean it's actually poly1. It's a copy of the pointer. So num now will store 2000, the address which is stored in the next field of num, which is nothing but 2000. We have allocated it in line number 22. And now num in line number 24, num of next is equal to null. So what we are doing here, in that newly created block of memory which we created just now, which is the second node, the address field of the second node will be containing null. So after line number 24, this is quite how a linked list looks. So we have two nodes in the linked list. The first node has all its fields filled, the coefficient field, the exponent field, and even the link field is filled. And the second node, only the link field is filled, that too with the null value. And the data fields, which is the coefficient and exponent field, are not yet filled, they're empty. In line number 25, now you can see we are asking the user, do you want to continue adding terms? So the user has to enter 1 if it's yes or 2 if it's no. Now let's consider the user entered 1. So which means he or she wants to enter another term. That value will be accepted into I, and also we are incrementing term. We are incrementing term so that if another iteration of while loop happens, we can prompt the user enter coefficient of term 2, of term 3, of term 4, and so on. Suppose if the user entered yes, I want to add another term. So we can go for the second iteration of the while loop. So now if we come to the second iteration of the while loop, we come back to line 18. Now the prompt to the user would be shown as enter coefficient of term 2, because it's 1 plus 1. We incremented term in line number 27 in the previous iteration. So we accept that coefficient into the C field pointed by num. Now what you have to consider is num is pointing to the second node right now. So since num is pointing to the second node, the coefficient field of the second node is filled. And similarly, we are asking the user enter exponent of term 2. So again, the exponent will be stored in the exponent field pointed by num, in the node pointed by num, which is the second node. And then line number 22, 23 and 24, as I explained before, these three lines, the function of these three lines is to create a new block of memory. So basically to create a new node. Now in line number 22, another node is created, which is the third node, and that address of that third node will be stored in the next field of num, which is in the next field of the second node. And num will now store that address of the newly created node. And in the third node, the link field will be filled as null. So now, when we come to line number 25, our linked list can be imagined like this. So we have the first node, which is completely filled, the coefficient, exponent, and the link to the next node. It's completely filled, there's no null value. The second node is also completely filled, coefficient, exponent, and there's no null value. But the third node, since we created it just now, the third node will have the null value in the link member, and coefficient and exponent are completely empty. Those fields are empty. Now I come to line number 25 and I ask the user again, do you want to continue? Now if I enter no, I don't want to continue. So I will store the number 2. And since I should be equal to 1 to continue the iterations, so the control will come out of the loop. Obviously the term also will be incremented, but that will be of no use because we are coming out of the loop. So now we totally come out of the loop, and basically that's the end of the function also. And now this control will go back to the main function. So now we come back to the main function, and as you can observe, like after we went through the detailed analysis of how to insert the terms of a polynomial into a linked list, you can observe that there was an extra node created at the end of the linked list, which we saw just now. So the user wanted to enter only 2 terms, but there were 3 nodes created. So the first two nodes were totally filled with the terms as the user has given, but the third node, which is the last node, it was an empty node, and also the link field was stored as null. So this empty node will be useful later on in the code when we add polynomials. Now you can see in line number 101, we are asking the user for second polynomial also. Now poly2, the pointer will be passed to the push function, and the similar steps will happen for polynomial 2 now. So it's the similar steps I explained before in the push function, but the only difference, it's happening for the second polynomial, which is for the pointer poly2. Now you can see in line number 103, add polynomial function. So we are passing poly1, poly2 and poly3. These are the head nodes, and it's passed to the add polynomial function. Let's look at add polynomial function now. So here in add polynomial function, these pointers poly1, poly2 and poly3, they're received by p1, p2 and p3 respectively. And the basic concept, now I would like to tell you the basic concept of this program. So when you add polynomials, the important thing is we have to add the coefficients of the variables which have the same exponent. So if I have 3x cube and 2x cube, so we have to add them, so which will be 5x cube. That's the main task. And suppose if I have 3x cube plus 2x square, we can't add them because the exponents are not same. So they are stored as two separate terms in the resulting polynomial. That's what we're going to do in this function. Now in line number 50, you can see there's a while loop. So next field of P1 and next field of P2. So this means that if the next field of P1 is not equal to null and next field of P2 is not equal to null. So which means if either of the next fields of P1 or P2 is equal to null, then the control will come out of the while loop. So now we get inside the while loop. So line number 52, you can see here it's given if exponent of P1 is greater than exponent of P2, then the following steps 53 to 56 should happen. So this means that if the first term in the first polynomial, if that exponent is greater than the exponent of the first term in the second polynomial. So in the first polynomial, think I have a term, the first term as 3x cube, and in the second polynomial, the first term I have is 2x square. Now since the exponent cube is greater than square, so which means the exponent in P1 is greater than exponent in P2. So since that exponent is greater, we store that 3x cube as a separate term in the resulting polynomial first. So you can see the if this condition is true, line number 54, you can see line number 54, the exponent of P1 is stored in exponent field of P3, which is the first node of P3. And coefficient of P1 is stored in the coefficient field of P3. So we are storing it as an altogether separate term because there are no matching terms. Because if there was a matching term, we would have added it by now, but there's no matching term. So since we have considered that term in P1, the P1 will be traversed to the next node. It will be continued to the next node. So basically this means that P1 is one node ahead of P2 if this condition is true. Suppose if this condition is not true, suppose if it's the other way, you can see in line number 58, suppose if the exponent of P2 is greater than exponent of P1, it's vice versa right now. So suppose if P1 I have the term as 2x square and P2 I have it as 3x cube. So it's similar. Since the exponent of P2 is greater, I'll store that P2 term as it is altogether as the same term in P3. So these are the steps 60 to 62. So we are storing the exponent of P2 in the exponent field of P3 and coefficient field of P2 in coefficient field of P3. And now since we have considered that term in P2, it will traverse to the next node, which is P2 is equal to next of P2. So here it's considered as that the P2 is one node ahead of P1. Now the last condition in this while loop, line number 64, else. So what if both of these conditions, above conditions, are not true? What is the other condition left? This means that if both the exponents are equal. So if both the exponents are equal, then we add them. So 3x cube and 2x cube, if these are our two terms, so cube and cube, they are equal. So we add the coefficients. So you can see in line number 66, the exponent of P1, it can also be exponent of P2. It doesn't make a difference because the exponent is same. So the exponent is stored in the exponent field of P3. That's fine. And now the coefficient in P3. So we have to add both the coefficients of P1 and P2 because 3x cube plus 2x cube, it's 5x cube. So the coefficients 3 plus 2 is equal to 5. So P1 of C and P2 C, the sum of these two will be stored in the coefficient field of P3. And now since both the terms are considered, since both 3x cube and 2x cube, both of them are considered, we traverse to the next node in both the polynomials. So next of P1 is equal to P1 and next of P2 is equal to P2. And now in line number 71, so obviously either of these three conditions has to be fulfilled. So after one of those conditions is fulfilled, the control will come to line number 71. So you can find some similarity with these lines 71, 72 and 73 with what we have discussed earlier. These are the lines which I discussed in the push function. So these three lines, the function of these three lines is to create a new block of memory, and it will be useful for storing the new terms in the next node. So basically we're creating the whole linked list in this function itself. So in line number 71, a new block of memory is created and that address is stored in the next field of P3. And P3 will store the address of that newly created block of memory. And that newly created block of memory will store null in its link field. That's the function of these three lines, 71, 72 and 73. Now in line number 74, that's the end of the while loop. So from line number 51 to line number 74, this is the first while loop. And if either one of the next fields of P1 or P2 is equal to null, the control comes out of the while loop. So when does that happen? So when does either one of them, like why are you saying either one of them? Can't it be both? No, it can be either one of them. In cases, suppose if the P1, now we saw in the first condition in line number 52, we saw that if the exponent of P1 is greater than exponent of P2, that term is considered in P1 and the pointer P1 is moved one node ahead of P2. So it's traversed because that condition is considered, term is considered. Now this means, suppose if P1 of next is equal to null, this means that all the terms of P1 have been considered. But that doesn't mean it's the same for P2 always, because there might be some extra terms in P1 which don't match with P2. So in such cases, either one of them will be equal to null. So that's when this condition will come into place. So after you exit this while loop, after line number 74, you can see in line number 75, there's another while loop. Why do we have this while loop? So as I said right now, the previous while loop, so the main function, so if either one of the next fields of P1 is equal to null, then the control will come out of the loop. So I even told you the condition, like why it happens, why either one of them. So in the example I gave you, the P1 terms are all considered, and P2 there are still some terms to be considered. Let's assume that there's one more term to be considered in P2, the last term. So if this while loop in line number 75, if this while loop is not there, then the addition of polynomials cannot happen because there's still one term to be considered in P2. We cannot just leave it like that. We have to consider it. So that's why there's this other while loop in line number 75. So if next field of P1 is not equal to null, or while next field of P2 is not equal to null. So only if both of the next fields of P1 and P2 are equal to null, only then the control will come out of the while loop. If either one of them is equal to null, it won't come out. So suppose in the example we took right now, since P, all the terms are considered, so next field of P1 is obviously null. So which means that P1 is pointing to the last empty node. So next of P1 is equal to null. But next of P2 is not equal to null as of yet. There's still one term to be considered. So the control will go inside the while loop, line number 77. And you can see here it's given next field of P1 if it's not equal to null. So if it's not equal to null, then 79, 80 and 81. These three steps will be followed. So we know that in our example, the next field of P1 is equal to null. So this condition won't be executed. We come to line 83. Next field of P2. It is not equal to null. So the next following steps, 85, 86 and 87, this block of code will be executed. So here you can see the exponent of P2 is stored in exponent of P3 and coefficient of P2 is stored in coefficient of P3. So this means that the term which is left out in P2 is considered altogether as a separate term because there are no matching terms with it in P1. That's why it has considered all the terms and it has traversed till the end because there are no matching terms. So we store this as a separate term in P3. Even in condition 77, in line number 77, so if it was the vice versa, if all the nodes in P2 were traversed and there was some terms left in P1 to be considered, it would happen the vice versa. P1, the term in P1 will be considered altogether as a separate term. So after these conditions, either of these conditions are executed, you can see in line number 89, 90 and 91, again like another block of memory is created and the linked list is continued. So this is our add polynomial function. So this is the function responsible for the entire addition of both the polynomials and also the creation of the resulting polynomial linked list. So after this, the control will come out of the function and it will go back to the main function till line number 104, which is the result. So we display the result to the user now. So in line number 105, we call the display function. Let's look at the display function right now. So this is the display function and you can see I have initialized a pointer num to poly3. So poly3 is the head node of the resulting polynomial and I have used temp is equal to num. So temp, as I have told you in the beginning, I told I'll be using it later on in the code, which will be helpful in traversing through the linked list. So to display a linked list, we need to traverse through it. So I'll be using temp is equal to num. So I'll be using a temporary pointer called temp. So the address stored in num, which is the address of the head node, will be stored in temp. Now you can see in line number 34, there's a while loop and it's given the next field of temp if it is not equal to null. So what does this mean? So the next field of temp if it's not equal to null. So this condition will, so the block of code within this while loop will execute until the next field of temp is not equal to null. So when does it become equal to null? It becomes equal to null when that last empty node, which I have told you earlier, the last empty node in the linked list is encountered, which means all the terms have been considered and all the terms have been printed to the user. That's when the control will come out of the while loop. Now let's look at the block of code inside the while loop. Line number 36. You can see that there's a if condition. So here there are three parts to this if condition. So temp of next of C. So now if I have, so suppose if I have 4 terms in the resulting polynomial, and I'm already in the third term. So the temp of next, which means I am pointing to the fourth node right now. The link field in third node will have the address of the fourth node, obviously. So I'm pointing to the fourth node. Now you can see that arrow C at the end of that condition. So arrow C, which means the coefficient of that fourth node to which I'm pointing to from the third node. So if that coefficient in the fourth node, if it's less than 0, which means if the coefficient of that next term which I'm about to encounter, if that is a negative number, then you have to print as given in line 39. So why am I doing this? So when you add polynomials, obviously there'll also be negative numbers, integers. So suppose if I have a negative coefficient, I have to print a minus. I cannot print 3x square plus minus 2x. I cannot do that. So it should be 3x square minus 2x. There shouldn't be any plus minus combination. So that is why I have printed %d x to the power of %d, but I didn't put the plus sign, because this is for cases when there is a negative coefficient in the next node. Now suppose if the coefficient of the next node which I'm about to encounter is not negative. Suppose if it is positive, we print the plus sign at the end of the term. This is because in C language, plus sign is not pre-built or pre-allocated to the term, but but minus is pre-allocated, which means we don't need to put the plus sign. So after we come out of the if condition, suppose in line number 36, if this condition is not true, then it will go to line number 43 else. So line number 36, okay, I haven't explained what line number 36 is. So temp of next to next, if it's not equal to null, which is the next node which I'm about to encounter, if that field doesn't have null, which means if I am not encountering the last node in the next traversal, then you have to continue with the statements line number 38 to 41. Else you have to go to line number 43. So why is this condition? So I have told you why we don't need plus sign in cases where there's a negative coefficient. We also won't need the plus sign if it's the last term of the polynomial. So if it's the last term of the polynomial, you can't say like 3x cubed plus 2x squared plus. You cannot leave it like that. So there shouldn't be a plus, which is why I have this condition. Else printf %dx to the power of %d, and there is no plus sign in line number 44. And then after either of these two conditions are executed, you come to line 45, and it's the temp is traversed to the next node, and that's the end of the while loop. And this while loop will keep on executing until you encounter that last empty node. Now the control comes back to the main function, and that's it. That's the end of our program. We come to the end of the main function as well. So I hope you have understood the functions of the push function, the add polynomial function, and the display function. The most important points in this program to consider is there's always an empty node at the end of each linked list, and also the method of adding polynomials is very important, especially those two while loops, so that has to be taken care of. Let's look at a sample input and output. So here in my sample input and output, I have taken two polynomials, 3x to the power of 4 plus 2x cubed minus 2x to the power of 0, that's the first polynomial, plus 7x to the power of 5 minus 10x to the power of 4 plus 3x to the power of 0. So as you can see from this equation I've given here, you already would have figured out the calculation in your minds. So now let's see if it's correct. So I have asked the user enter first polynomial, enter coefficient of term 1. So the user has entered 3, exponent of term 1, user has entered 4. So what is the term now? 3x to the power of 4. So the equation I just showed you now, that I'm showing it to you in the program form, how it will be displayed to the user. So do you want to continue adding terms? I gave a yes. So this will go on, and now you can see over here, you can see here, enter second polynomial. After entering 2, which is no, I entered the second polynomial, and the same steps are followed. We keep on adding terms until we want to. And you can see the last line in the output, we got the result. So 7x to the power of 5, there's a minus, which means there was a negative coefficient, minus 7x to the power of 4 plus 2x cube plus 1x to the power of 0. So this is how our addition of polynomials using linked lists works. Thank you.